So when you have to store the data, one way is you can store it in the file system, but then accessing the data will be really tedious. Okay, and it will not be very performant from the performance perspective, and you have to do lot of coding to extract the data and manipulate the data. Okay, so when we are talking about massive amount of data, file based solution will not work. That we are accessing the file and we are writing and reading from the plain file, that will not work. So for that we start using database. Okay, database is this is the common symbol used for database. It's like cylinder. Okay, sometimes there is mark also here which is showing multiple disk in the database. Okay, so you will see that, okay, database will be shown as cylinder. So many times when I will represent as cylinder. So that's where you actually start keeping data, and so the place where you store the data is called database. And as Parth, you were saying, it's a structured way of storing data, right? So database provides us structured way of storing data, very structured, well structured. Now the advantage of structure is your retrieval and saving the data, finding the data, searching the data, all those becomes super efficient, right? So that's what we will be looking at. Database is extremely important. I think 99.99% system would have some data. I'm saying not even 99. I think almost every system will have database with them, because every system will be dealing with some data, will be generating some data, and it will be storing that data. Okay, so so pretty much all the systems have a data storage mechanism. Okay, right. So for that, like database is extremely important. So we will actually look at the first database, which is called SQLite. Okay, and in SQLite there is something called SQL. Okay, SQL is a structured query language. Okay, it's a kind of a programming language of its own. The structured query language which you will use to access a database from Python in the same way you'll be using from other languages. For example, if let's say I have this database, now database will be external to the Python program. Okay, so let's say this is my Python program. So when this Python program executes, it can talk to the database and retrieve the data from it. Okay, so it will talk to the database and retrieve data from it. And when it is doing, we also say that no, it is doing IO operation. So what is IO? What is IO? Any idea, anyone? Yes, no?
Input, output.
Yes, it's input, output. So we call it input, output operations. Okay. So input, output, when we're talking about input, output, whenever you do, you have to understand that Python will be going out of its memory space and will be accessing something which is actually not part of the program, but it is staying as an external entity. Okay, it will not be inside the program, it will be staying as an external entity, and Python is reading that. Like for example, when we are using file, right? Files, txt. So this was a external entity, right? So we were doing IO for that to read this file, read and write to this file. Similarly, when we are doing it for database, we say that, okay, this is IO operation, which means database will be a file which will be created, okay, which will store the data. Okay, so it will generally can have extension as .db, or it can, you can put any extension, but yeah, .db can be used for to represent a database. Right, so now eventually database, wherever the data is stored, of course it will be internally, it will be file system only. It will be a basically file, okay, it will be just a file, right? But the data which is stored in this, first of all, you will not be able to see it just by opening the file. It will be all in binary. Okay, it will be all in binary, right? Which it will not be in normal text. It will be all in binary, not in normal text. So you, to read this data, you will have to use some, you will have to use the APIs to access that. Okay, so that API is able to read that binary and it's able to make sense out of that. Okay, so okay, what is binary?
The language that computer reads in. So
Yeah, so
0, 1, 0.
binary, yes, you're right, Prabha, that it's like it will basically in zeros and ones. This is eventually how computer will read the data. Okay, so when we say binary data, simply you understand that it's not a readable data. Now this binary data can also be represented in like hexadecimal number also, so it can be FA98, something like that also, right? But just understand that, okay, it's a binary file. It will not be directly readable by human eyes. You just cannot open it in a text editor. It's not a text file. It's a binary file. Okay. So let's, okay, so now what I was saying is, so when we are accessing this database, we will use some kind of SQL, right? Let's say I have another program which is written in Java. And this is also, this can also access the same database to retrieve the data. And when it is interacting with this database, it will also be using the same language as SQL. Okay. So SQL is the language of the database, right? So using that, you can do operations with the database. And this is the only way through which you can interact with the database, read the data, write the data, perform different operations. Okay. Fine. So far, so good. Is it clear? Is it clear? Any confusion? Any question?
No, it's clear.
Okay. Fine. So now we will look at the smallest database, but very popular and heavily used. Okay, it is called SQLite. Okay, now this SQLite database, when we start using, as you know that, no, to access this, we will have, so we will have to use the basically the way we will access will be using SQL only, right? Now before that, so when we also call SQL data, when we say, okay, SQLite is a SQL database, we'll say SQLite is a SQL database. So SQL databases are also called RDBMS, which stands for relational database management system. Okay, relational database management system. So this is something which you should remember, RDB, are DBMS. So SQL databases are actually RDBMS. Okay. So now SQL database or RDBMS, do you guys remember, or can you guys tell any names of the databases? Do you guys know of any names? Maybe not. So SQLite is one of them. There's another one called Oracle. There's another one called MySQL. These are RDBMS database, the popular ones. There is another one, PostgreSQL also, PostgreSQL, which is also popular. So these are the pretty much popular databases. Other than that, in relational database, I don't think any these days. Yeah, there is one more, which is MS SQL Server, which is like Microsoft's. Even that is being used. Okay, that's also popular in Microsoft world. Okay, so now why it is called relational? So let's understand that. Okay, so why it is called relational. So let me just make it clear. So relational. Okay, so the data which is stored in this type of databases, relational SQL or relational databases, are in form of tables. Okay, now tables you can just simply understand that, no, tables which you see in Excel, right? So what do tables contain? What do tables contain? If I say this is a table, what will table contain? What do you see in Excel?
Like on the sides or
Rows
Yeah,
and columns.
rows and columns. Excellent. Yeah, so it will have rows and columns. Okay, so it will have rows and columns. Okay, let's say this table, and we in databases we call them tables. In RDBMS relational databases we call them tables. Okay, so let's say we are creating some kind of a student management system, and we have student database. Okay, now let's say student is John. Okay, this student is John, and he's probably in grade 6, and he plays football, right? Some details about John, right? Grade 6 and football, and maybe uh, father's name. Father's name is, I don't know, like maybe Smith. So this is, we say that this is one student's record. Okay, so we'll say this is one student's record. So we call it record. And this one student record will actually go in this one row. Okay, so then, so now you see that the way, if we have more students, let's say another student is Ron, and he is in 7th, he likes to play soccer, his father name is uh, Ryan, right? So something like that. So these are different records. This is record 1, this is record 2. Like that, you can have many records, and each record will actually go in one row. Okay, and each record has values. How many values are there in each record? How many values are there in each record?
4.
4. Very good. And then, so the name of the, so we say that, no, what are the column names? Okay, so this column name is actually name. Okay, and this column age is like grade. Then you have sports, sport, and then you have father's name. right? So this record will actually go in this. This record will go in this. Ron will go. Record will be here. Ron, 7, soccer, Ryan, John, 6, football, Smith. Like that, it will be there, right? So that's how. So when we are defining a table in the database, we will first tell what are columns are there, because that's what we have to tell. No, what are the columns? What are the columns which will be there? there, and what is the data type of each column? So this will say, okay, this data type is actually string. This will be int. This will again be string, and this will again be string, right? So we tell these are the columns and these are the data types, right? So that's how we will be able to create one table. But now where does this relational comes into picture? So what happens is, now this is one record. So we are talking about student management system. So this is just one record, right? Just the student this thing, but there will be other details. Let's say there's a detail about the class, right? Class. So now classes. So there will be classes, or you can say sections, right? So now this will be there. It can have other records. It will have like class 6. Teacher of the class is Simon. Okay, teacher of the class is Simon. So, and then how many students are there in the class? Let's say 25, right? So these are some records. Okay, so the class teacher is this and this thing. Now John, now John would be studying. So now this is classes. This is classes. Now John will be studying in one of the class. So now this we can say that, okay, this will be this, we can assign it as a, the first record can be the ID of this. ID means using this ID, you can identify one record. In fact, in this table also, you can have an ID. You can have an ID. Using this ID, you can identify one record. So we'll say, okay, since this student table is related to classes table, whatever ID, let's say John actually studies in 6. So even if you don't have ID, you can actually use the 6 itself that represent, okay, so this table, students table is related to classes table. Okay, class table. Student table is related to class table, and John is actually part of this, right? Because this is 6. Now this can be number or this can be ID. You can associate the two records from this. Now if we have to tell who's the class teacher of John, how will we find that? How can we find who's the class teacher of John?
So like, cause like grade 6, he's in grade 6. So we're defining that like in the where we wrote Simon and class size is 25. So we have a number 6 over there. So it's talking about grade 6. So and
Yes.
John is in grade 7. So it would refer to John.
No, Ron is, we have not defined anything about 7, right? So
Yeah,
that record we
so
have not seen.
Ron is in grade 7, so the number is not grade 7, it's grade 6. So it's referring to John.
Yes. So if we have to find that who is the class teacher of Simon, so as Prabhu, you said that, yeah. So first of all, the question is, who is the class teacher of John? So first we will look into students table. John studies in which class? Okay, John studies in class 6. Fine. Then you will look at class table. Who is the class teacher of 6? Then you can find this record. Okay, Simon is the class teacher of 6, right? So you see that there's a relation between these two tables, right? These two tables have relation, correct? The data in this will have relation with this. So that's where we call it relational database. Like that, any system you take, one table which contains the data will have a relationship with other tables. It can have relationship. And many times we say that no, foreign key relationship. Okay, foreign key relationship. So those kind of things. So that's why we say that no, it's a relational database. Okay. So so in relational database, the data is created in form of tables, and we use SQL to access the databases. Other type of database is called NoSQL. Okay, it is called NoSQL, where we don't store the data in form of tables. Rather, we store data in form of collection. You can think about, we store the data in form of dictionaries. Dictionary data type, you know that, right? In Python, which has key value pairs, right? So that's how we store the data in, and we call that as collections. We don't have tables there, we have collections there. Okay, so we will not go deeper into NoSQL, but just for your information, I'm just telling you that no, it's a NoSQL database. And now this guy is gone. Okay, so let me just see that screen. So I'm just telling you for your just knowledge, so that you're able to, you may hear a lot of databases. So NoSQL databases are Mongo, then Cassandra, right? There are few more databases which are there, but you don't have to worry about it. The main thing you have to understand is the relational database at the moment. Okay, just for example, in NoSQL database, as the name suggests, we don't access the data using SQL, and we don't store the data in tables. Okay, the data is stored in form of collections as key value pairs. Right? Fine. So now let's start looking into SQLite. Now good thing is SQLite comes bundled with Python itself, so you really don't have to install anything. It is directly available to you. Is directly available to you. Okay, so you just have to kind of import, and then you're good with the database. Okay, so let's write one today. I think it's session 4, right? So we'll say new file, and we'll just write one simple. Okay, yeah, so we'll say product store.py. Okay, and then we will just start using is just SQLite 3. Okay, so there's a SQLite 3 version which we use, and that's directly available in Python. You don't have to install it separately. Okay, so now in this you don't see that no, we have any database file. We can actually create a database file. So for that, we will simply say SQLite 3 dot open, or rather connect, I think. So let me just refer to this. So it's called connect, right? So you connect to what? Connect to a database. So that's where it says in database, all different values are there, but we have to provide a database name. So we will say database name is product products. We can say .db is just an extension which you have to give, and then we can so we can actually, so once we create that, so this is going to give me the connection object. Now we have created this connection. If you remember file operation, we used to get a handle through which we can access the file. Similarly, you get a connection object because with database you will be creating connections, and using the connection you are going to access that. So you can do various things. So as of now, let's just close this, and you know that now any resource which you are open, you have to close it. So session 4, let's run products, right? So we run it. You see that this database has been created, and you look at the symbol also. It looks like the cylinder. Okay, even though it was not there, if it is not there, Python will create it. If it is there, Python will use it. Okay, so you see that it's not creating anymore, it's already there. Okay, so it is using that. Once you connect this, you will have to you want to actually create a table. Okay, so to create table, we will have to use SQL command. So let's use this command. Okay, so we can use this command. We can actually, so the command is, so it's basically is going to be string, and we can call it as statement. Create table, and in simple terms, you can just say store, and then you have to define the column names for that. Okay, so create table store, and then you will say that, okay, ID is integer, and we can say it's a primary key. Then so I will tell you what primary key is. So we say integer, ID is integer, it's a primary key. Then we will have name. Okay, name of the product, it's a text, right? And then we can have price, which, okay, we can say it's float. Okay, so once we have done that, we will have to execute this. This is just a string which we have created, which is actually it's a Python string, but we have SQL statement in it. So we will say, we'll have to create a cursor object. Cursor object, the one which you see, the cursor which is blinking here. So similarly, to manipulate database, because you will have rows, so you will have some kind of cursor which you will use to manipulate things. So for that, you will have to just create a cursor object using connection. So I'll say, okay, cursor is equal to this. Now using cursor object, we will have to do any DB operations. Okay, so we will say execute, right? And then when we execute, we'll say, we'll pass on this statement, right? And I think this is it, right? So now we have the table there, right? We have created the table there. Now, how do we know we have created the table? If I try to rerun it, it is throwing me error. See, it says table store already exists, right? Say table store already exists. That means we were able to create the table. Now, since it already exists, so we can also add small thing in this, that no, if not exists, then you create store. If not exists, then we create this thing. So now it will at least not give me an error because this table already is already there. Okay. Now see this SQL, this is a SQL statement. Okay, this is a SQL statement. Is case insensitive. SQL statements are case insensitive. Okay, but as convention, the SQL related queries or SQL related terms, we write it in all caps. And when it comes to your application specific thing like store, ID, name, price, these things we are writing in lowercase. But for SQL specific terms, we are using uppercase. Okay. So now you see, for each column, we are assigning a data type, right? Integer, text, float, right? Now we have marked ID as a primary key. Okay. Now the so in RDBMS, the primary key columns have the value which is acting as an identifier, which means they will be, you cannot have another record with the same primary key. Okay, it will be exactly different primary key. Okay, so it will be unique records used to identify the record. Okay, a record. So I think you may not be able to read it. Record. So because we are creating, we are creating like name of the products, and then we're just putting the price. Okay, we can also say maybe quantity available, right? So quantity available. So quantity, we can again say it's integer. But now since this table is already there, now this database is created. Okay, so we want to add this column to it. So since I don't have any record, I can drop this table, I can delete this table, and then I can recreate it. So see, using Python, I can interact with it, right? I can interact with it, but I can also interact directly to the database also, which is much more effective, much more easier to access. Okay, because if you're dealing with a large amount of data, it is much easier to access. So see, I have this database here, products.db. So I can actually access it directly. So I will go to terminal, and you can actually install SQL Client on your computers. Okay, if you are on Mac, you already get that. But if you're on Windows also, you can install SQL Client, SQLite client rather. You'll just search for SQLite client and you can install it. So I'm just going to this location and I'm saying SQLite 3, and I'm giving this product.db, right? This is the database I want to look into. So I'm connected to this table, and I can see that no, if I say select star from product, no, sorry, store. That's my table name, na? Okay, no table store. Okay. Oh, I have created there is already another table. Okay, so there is. So I think I have to use products. Somehow it was already there. So products. So now if I use this command, so it does not give me any record because it is not there, right? There's no record. We have not inserted any record in this. We'll just drop this table, drop table store. This table is gone. Now if I create, even if not exist, even if I remove it, it will all work fine because my table has been dropped. Now I can actually, I have recreated the table. I can now start inserting the record. Okay. So I can use the same cursor, but I will have to use different statement. Not to insert, I will have to say, let me just take it from here so that I will just say something like this. Let me write it. Insert into, and then I will say store. See, it's all in case instance sensitive. Even if I put it capital, it wouldn't matter. But I'm just insert into store, and I'll say values. Okay, and then I have to pass on the value. And since this is the primary key, I will leave the first to null. Okay, I'll leave the first to null. So in SQLite, it will automatically assign it an ID 1, 2, 3, 4, 5. Okay, because I'm leaving it to null, it will auto assign increment increasing order 1, 2, 3, 4, 5, and you can use that to access that record. So null, and then I'm saying name is let's say Apple. So here, since it's a string, I can actually use double quotes because otherwise it won't allow me. And then name is Apple. Price, let's say it is 5.5. Quantity available is, let's say, 50. And then we will just simply execute this statement. And when we execute, so now if I go there, still you may not see that because we have not done one thing. Okay, what we have done, we have to do something called commit. It's a connection.commit. Connection.commit. Okay, so I'll explain you what exactly is commit and rollback. So now let's run this. And now if I check, now you see we have got this data in the database, right? So I've got Apple 5.5 and 50, and this is the ID it has automatically assigned. Now if I keep running this, it will keep on adding same data with different IDs. So if I check here, see that I've got Apple multiple times, but with the different IDs because we have made ID as primary key. Okay, right. So this is how we can actually make inserts in that, and we can actually use SQLite client to access this data as well. Okay, so generally, if I start writing all this code, it will the code will become a little bit unwieldy because let's say if you're creating some kind of application, let's say you're creating a front end also to access these products. Sometimes you will have to do insert, sometimes you will have to do update, sometimes you have to do delete, right? So it makes sense to make different functions to do all that. Okay, so you can quickly actually do this functions. We'll say define create table, and this will all go inside the table. And we can also do like get connection. So that because every time we get the connection, we use it and then we close it, right? So we will just simply return connection, and then to get the connection, we will just call it here. It will give me the connection. Get connection. Okay, so it will give me the connection. We execute. But before that, let's get the connection, because we will have to close the connection. We will have to close the connection. So we get this, and then we will put connection here, right? So this will create table for me. And then I want to insert records. Insert record. And to that, we can pass the name, price, and quantity. Okay, so because we are inserting the record, we can do all that. And we will actually get the connection from here. And we will have to get the cursor from here. And then we close the, after we are done with the transaction, we cursor dot close. Okay, fine. So the same thing we have to do. So, okay, so in table, you see that in table, we are not doing commit there, but still the table creation happens. Okay. Guys, making sense? You guys are there?
Yeah, just like might have to go over once again, like just for more details.
Okay, okay. Yes, right. So yeah, we will be looking into more details as we progress. Do you have any specific question which you did not understand?
No.
Okay, fine. So see, what we have done so far is we have understood what is database, what is relational database, how to create. So you've seen all that no, to access the data, we have to store the data. And to store the data, we need a table. And using this command, so this is my statement, right? This is my statement, which is called SQL. This is my statement, which is structured query language. Okay, structured query language. So I've created this, and then I have executed these records there, right? So I have actually, I have to first create the table. Like that, I can create multiple tables in one database. As we have looked into student profile database, we can create multiple tables. Similarly, we can create multiple tables. So you need to have tables first so that you can start inserting the data in that. Okay. So whenever you're working on a project and you're designing the system, you will have to first design the structure. Okay. And when you are making your system live, you will have to create all the tables there. You will have to create all the tables using some database script or something. You don't have to run. So that creation of the database and all the tables you will have to do before users start using your system. Okay. So all that structure should be ready. Like for example, your Excel should be already ready, right? Then only we can start adding the data. Like for example, do you guys use Google spreadsheet?
Yes.
Okay, so in Google spreadsheet, the spreadsheet should be created. Okay, should be created before you can start adding data to it. Similarly, when you're designing a system, when you're making the system live, your database has to be ready with all the tables in it. Okay, then only people will start using that to insert the record and retrieve the record for different purpose. Okay, so it's a storage mechanism. Now, yeah, I'm saying, are you guys clear about the purpose of the database? Why we need database? Why we are no? Why we are storing data and why we are retrieving data? Is it clear to all of you? why we are storing data and why we are retrieving data, the purpose of the database. Is it all clear?
Yeah.
Right. See, like for example, another example can be your bank transactions, right? There are credits to the bank, there is a debit to the bank. What is the final amount there? There are so many customers there. For all that record has to be stored in the database. Okay. So their bank can use more sophisticated database. SQLite is a lightweight database, but banks can use maybe Oracle or maybe MySQL, right? So they can use those databases to store the data. So we have created the table and then we have inserted the record. Okay. So when we are inserting the record, we we call it that no, we are actually manipulating the data, because either you're inserting the record or you're updating or you're creating. So for that we call it an operation called CRUD. Okay, so we say that CRUD operations, we are performing CRUD operations on the database. CRUD, and this is for data, not this is for data. Okay, so this is for data, not the table. So we don't say CRUD for table and all. Okay, so we only say for data. So what does, I don't know why this keeps on hanging. Okay, so this C stands for create. So we say create record. R stands for read. Come on, this is, let me write it. So CRUD. Create, read, update, delete. Okay, so that is what is CRUD.
We can't see.
I'm sharing my
Like the
screen.
create, like yeah, now we can see because it was on the corner. So
Oh, it is on the corner, but I'm sharing my whole screen. You can see it, right? You're not seeing. You're
oh wait,
not able to.
it's my view, I guess.
Okay, got it. Yep. Fine. So that is what is CRUD. Okay, so create. So we are talking about records. We are saying okay, CRUD on records. Record is just one row of data. Okay, one row of data. So that is we can do CRUD. So we have seen CRUD, C of that, insert, right? Similarly, we have other operations for read, update, and delete. Okay, so that are other operation. Now, one thing, for any structural change which you do, we call it. So these are terms. If you can remember, well and good. If you don't, yeah, don't bother about it. These are just some terms you will anyway encounter later. The main thing is to understand how to use database. So for creation of the database structure, because when we're creating the table, we are changing the database structure. We call it DDL, database definition language. Okay, and when we are dealing with data, we call it DML. DML, which is database manipulation language. Okay, so which is again your SQL, right? Your SQL is the DML. So database manipulation language. So for DMLs, we need, when you're modifying the data and all, we need the commit operation, commit, and there's something called rollback as well. Okay. For DDL, which is changing the structure, whether you're creating the table or you're dropping the table, you don't need that. commit. Okay, now why is commit and rollback is required? Okay, why commit and rollback is required? So there is commit and then there is rollback. Now we did commit, but if you had done connection.rollback, the changes which you did would not have got persisted. Instead, they would have been erased till the point of the last commit. Okay. Now, why commit and rollback is there? It is for your data consistency. For example, consider that you are transferring amount from one account to another account. Okay. So there will be two statement have to be executed. One is deduction and one is credit, right? Now let's say the first statement got executed, deduction did happen, but before the second execution could happen, the database went down, okay, or the server connection got disrupted, right? Which means your program was running fine, but it is not able to access the database now, right? So in that case, your data will become inconsistent if you commit that data, because you deducted the amount, but you did not commit that amount. Okay, you did not commit that amount. And this kind of scenario is very well possible in the internet world. Let's say even a hacker comes in between, he does something, right? So it is possible. So for that, if that, so this will be part of that. Okay, if this succeeds and this succeed, then only go ahead and commit. If this succeed and for some reason this failed, then do a rollback. So that's why we have this commit and rollback. Okay. So is this concept clear? Commit and rollback.
Yeah.
Okay, good. Okay, so we will actually look at other DML statements. So let's take a break of 5 minutes. We'll be back at my time 38. Okay.
Okay.
Okay. So let's look at other transactions. Okay. So now see, this is not to invoke, make the I can simply actually call this, but since my table is already created, I don't have to really call. But to insert record, I can simply call insert record, and I can pass values as Apple 5.5 and then 50. I call this value and this values will go there. And then we can actually replace this by question marks. Okay. Because these are values we want to bind. So I'll come to what is the advantage. Just a second. Okay, so we call them as bind variables, and to use them is we will just simply, okay, so we will, when we execute set, okay, right, so when we actually execute this, we can pass these values. Okay, and these values have to pass in terms of tuples. So let's say this is orange and this is, let's say, $3. Now we are inserting the record and then we are saying execute statement and then we're passing the values. Let's try to insert this. Okay, so module numbers is also what did I execute? Product. Okay, has no attribute integral. Okay, so this has to be 10. Numbers. Okay, where is numbers? Line number 3. And line number 3 is matplotlib. My matplotlib is gotten. Connect is not defined. Okay, so we don't have to say connect. We have to get the connection here. And this is connection. Right. So yeah, I don't think so. We have to really worry about this, I guess. Now let's look at the SQL. Now if I fetch, now see we're getting orange, no? 3 and so we did the insert for 2 times. So now what we're doing is we are actually binding these values that, okay, we are passing 3 values as question marks and I'm going to pass this value as tuple. Okay, as tuple, comma separated. If I was passing some value, let's say I'm just directly hard coding some value like and then whatever value I'm passing, I'm actually not using that. In that case, I can actually use this kind of thing. So first thing, I'm just putting it down 1.5 and this is, let's say, 1000. So now you see that. Very good, banana, right? So since we have 2 question marks, we just need to pass 2 values in the tuple. So that's how you can use the bind variables. So these are placeholder values. And then along with the statement, we can pass this values to it. Okay. So this is how we can actually insert. And you see that no, we have got the connection. Connection was created and given to us. We created cursor object. Then we did commit after the execution. Then we did cursor close and then we did connection close. These are resources, database resources. You have to make sure that whenever you are consuming resource, once the job is done, immediately close it so that others can use it, because these resources are very limited. When we're talking about a full-fledged, let's say, database, you're using MySQL or something, there could be millions of users connected to that database, right? But the maximum connections possible in MySQL database is maybe 1000. Then how a 1000 connection can cater to million users? So the idea is you take the resource for a particular time. When you're done with it, you release the resource, you release the connection so that others can use it. So that's how we actually will be able to use a limited number of connections for large number of users. So this is insert record, and on the similar lines, we can create other functions as well. So we can say update, and we can say, so let's do update. So in update, what are the, first of all, you need values. Okay, you need values, and as well as you need the ID, right? Because on ID, on the basis of the ID you want. Okay, so before we get into ID, now see, I'm running this again and again. I'm firing this statement. This is actually a query which I'm firing. It's called query. So it's actually query which I'm firing. Okay, so we also call database query, structured query language, or for all that the same thing. But here what I'm saying select star from store. Star means give me all the columns. Okay, and this I can also say select name from store. So you see, it is just giving me the name column. I can say select name, comma, quantity. It is giving me quantity. Okay, so that's how I can select individual columns as well. If I'm putting star, I'm saying, okay, give me all the columns. Okay, and then I can filter the records also. I can say where name is equal to Apple. That will just give me Apple records, right? So I'm able to filter. I'm able to apply this condition, right? Or I can say where price. So yeah. So where. So I can also combine where price is greater than 2. So it is able to give me so name, quantity, and price greater than 2. So they're giving me these records. Okay. And you can say like no price greater than 1 and quantity greater than 100. So for that only this record will match. These will not match. Okay, so see only banana and 1000 is matching this criteria. So we are passing this criteria. Okay, we also call it where clause. Okay, so this is the where in it, right? So we call it where clause. Where clause. So this is the where clause. Okay, this is where is the keyword, and this is the where clause. Okay, so these are part of SQL. Okay, these are part of SQL. And once you learn for SQLite, it's the same SQL which you'll be using for other databases. Right. So now update record. Before that, we can also do read record. Right. So we can say to read record, or we can say search record. Okay. So to search record, I'm passing name, price, and quantity. And I'm trying to search for a particular record. So I can say select star from store where, and this I want to write it in caps. Select star from store where name is equal to question mark or price is equal to question. So or is if any one of them this match, I will be it will match the record. Quantity is equal to question mark. Okay, so we will do all this and then get connection and then get basically cursor, execute this, and then we can pass these values. Okay, we can pass these values, which is basically the tuple, right? So we already have price, so I'll just add name to it, right? So this statement will be executed with whatever value we pass, it will be executed. And when this execute, it will return us rows. Okay, so it will return us rows. And after executing, we'll have to call this cursor.fetch all to get all the rows. So we will say, and in this case, since we are searching, we don't have to do commit because we're not changing anything. So we don't have to do commit. So we will say cursor.fetch all, and this gives me rows. And after that, I can actually close the connection and all, and then I can return rows. So then I can actually come in this and I can fire rows equal to search. Search record, and I can, let's say I'm passing blank and price I'm passing 10 and quantity I'm passing 50. Okay, so I know that there's some records which match 50. You see that it is matching, all this record is matching 50 quantity. That's what I'm passing. So any one of them, if matches, it will give me that. So if my price I had put 1.5, now I know that no, banana price is 1.5, even that will show up. Now you see even banana has been included. Okay, accordingly you can frame this. Okay, so here we are searching only for the exact values, but if you want to create that no greater than or less than, so accordingly you will have to frame your query, and you can actually create your function accordingly. Okay, so search record we are doing on the basis of any of the values. Update record, now to update record we will have to find exact record ID and then update that particular ID. So for that, not only we will need the values, but we will also need the ID. So we will have to also pass the ID column, and then the update record is, the query is update store. Okay, then you'll say set, and then we will say name is equal to question mark, price is equal to question mark, and quantity is equal to question mark, where ID is equal to question mark. So this is my record, and the same thing we will execute statement, and we have to send in the particular order. So you see that ID has to come in the last. So we will be sending ID in the last, and yeah, ID is also recognized keyword, so that's okay, shouldn't matter. Name, right? So now update record and all that, and then we are checking on ID, right? So now we can actually simply call this, update record, and we can pass these values. So we want to, let's say, update ID 1, and we from Apple we want to change to some, let's say, mango. Then price is, let's say, 9, and then quantity is 250. Okay, and see, since update record is a DML record, we are changing the data, so we have to commit. So we have done this. Now let's check it there, and you see that now we're getting mango as well. Select star from store. So we're getting, even the first record has been changed to mango. So that's how you can do update. And then the similar lines, we will have delete as well. Delete will be the simplest one, because for delete you just need to send the ID, because you want to delete only one particular record. So we will say delete from store. Okay, and then we simply have to say where ID is equal to question mark, and we don't have to pass all this. We just have to pass ID, right? And since we have to indicate that this is double, we have to put it in the comma. And I can actually comment this, and let's say update, sorry, delete, this should be delete record. Fine, so we have to delete record, and let's say I want to delete record with ID 2. So let's do that, And if we try to delete it again, okay, it's not throwing any error, but let's check this out. So the record is actually gone from here. It is not throwing error because it is not finding it, and that's okay with it. But it is not impacting any change because it's deleted, but we can say that no, it's already gone. Okay, so this is how you will perform CRUD operations in the database. Okay, so so these are the database commands, and this is available to you on Robopreneur. And you can actually download SQL Client. Okay, SQL Client, so that you can see it. So SQL Client for Windows, you can get it from there. Right. So these are the different things. Now, SQLite is actually a very lightweight database, and generally what happens is SQLite is bundled with the application itself. Okay, SQLite is not meant as a full-fledged database. Now, the reason SQLite became popular and it came into existence was because of the mobile apps. Now, mobile apps, if they have to support offline feature, they need to have data available, right? They need to have data available on the phone itself. So SQLite gives that organized way of storing and retrieving the data. So that's why I'm saying you cannot store a you cannot have a full-fledged MySQL or Oracle database on the phone, because phone will have limited capacity, and also you will have a lot of apps which will be there. So every app will can create its own small database using SQLite and can perform the transactions. Okay, and SQLite is pretty sophisticated and popular in that. So that's where, but yeah, the to learn about SQL and RDBMS, it is pretty good, and it is actually pretty much the same the way you deal with other databases. We will look at one full-fledged database, which is MySQL, and it's free to use, which you can even use it for projects, and it is used by professionals in no real life production applications as well. Okay, so this is about database. So before I move to the next topic, do you guys have any question or everything is clear? Any question, guys?
No.
No, I think it's okay.
Okay, fine. Okay, so now actually the next topic is basically okay. We have completed all this, so we will be integrating GUI with database. So what I will do is I will actually quickly go over this. So this we have, okay. Building so we will quickly build this bookstore application. I will not be spending too much of time. I'll share the project. You can go in detail, but pay attention. If you don't understand anything, you please stop and let me know. Okay.
I have a question. So
Okay,
was
go
this
ahead.
like the last lesson? Like, cause on the Robopreneur, after SQLite, there's nothing else.
There's nothing for this application, this particular one.
Like,
You mean for bookstore, or
you know how we do
yeah,
like there's
see
a
these things, see SQLite and TK Inter assignments will not be there on Robopreneur, because you see that no, TK Inter will create a UI, right? So there's no
yeah.
way to build that in a website, and also database, if the file is created, will be created on the server side, so you will not be able to see that. These things you will be doing more in lab to get more practice. Okay, and then there you can work and work on it. Okay, so but yeah, notes and all these things will be available. If they're not, I will actually upload them for your reference. Okay. So this is basically the front end. Yeah. So any other question? Is that clear to you, Prabha?
Yeah.
Okay. So now when we build this, so whenever you're doing software development, you have to take care of the organization of your software so that the software maintenance is easy and you can actually uh, if in case there is issue or if you have to enhance, you can easily enhance that. So the way we generally build application is that now if you have, let's say, okay, so if we do this, yeah, so if you have UI, so we say that this is client, then you will be talking to this database, right? So you have to talk to the database. Now what happens is from UI, generally to keep the code clean and separate, you will not have the database code in this. Okay, you will not have database code in this. Okay. So what you will do is we generally create a layer for database layer. So we can call it as a backend layer. Okay, and this is UI, or you can say client or something. So to do any operations on this, so the purpose of this file will be to take for the UI creation. And basically displaying data, providing controls to the user to manipulate the data. Okay, so when any action, anything happens, this UI, when UI has to make the database change, it will call a function of backend to do that certain thing, and that backend is going to actually make the update in the database. Okay, update in the database or fetch the record accordingly, it will do. Okay, so that's how we will be building this. So so let me just take out one. So Bookstore. Okay, so Bookstore. So we have this front end. So you see that the front end is just simply creating our UI. Okay, how it is creating our UI is. So let me just run this so that you see the UI. Okay, store. Front. Okay, so this seems to have some problem. Let me go to another one. So store 2. So Python 3 front end. So you see that this is my UI, basically a bookstore, my bookstore. So the idea is that now I will have some books. I will be able to view them. Think about a simple library management system. So when I click on view all, you see that I'm getting all these books which are there, right? I can select a particular one. I can delete them, right? I can delete it. I can actually select particular one, and then I can, so the values will change here. See, the values are changing. And so I can do all that. And if I come here, I can change the values also. So I can say Lua 2 or something like that. And then if I update, see that this value has got Meluha 2. It has become Meluha 2, right? So the value has got changed. Okay, so I want to change the date to 1998. and Malua 3 update. So see, this has got changed. Okay, so like that, I'm able to perform these operations. I can even search for certain things. Let's say I want to search for author Amish Tripathi. That no, what are the books he has written? So I'll just simply do a search. You see, I'm getting all the books which are written by Amit Tripathi. So I can do perform search. So now this gives you a capability of writing a full-fledged application which has a UI as well as you have a database to interact with. Okay, and everything is done through Python. So this is what we will look at to build. And so I will actually go to Bookstore 2. So if you look at this, okay, let me just first close this so that there's no confusion. So you look at this front end has a code pretty much to build all that, right? So what are the front end code? So you have some labels, you have this entry, and you can see that, right? So these are labels. This is entry, which is actually text box. Then you have this list box. So if you look at this, so you have this year and ISBN, and then you have this list box, which is my list, which will show multiple records. I can add record, delete record, all that from it. Okay, then there's a scroll bar also, which is okay. If I have more records, then it will start showing the scroll bar. Then we have this view. Then I have all these buttons here, right? So view button, search button, add button. And I think all these things you must be comfortable with, isn't it? Creating this kind of UI elements.
Yeah.
Okay. Uh, we are using grid layout. So we are just simply specifying rows and columns, and then simply we are doing it. Okay. So you all should actually try to build this, even though I will send the code, but you should first try to run that code. And when you get the UI, you should try to build yourself. You can refer to the code, but wherever you have confusion, but you should give it a try without actually looking into it. Okay, so once you have done all this, right? So then what we will do is we will have to create these functions, right? We have to create these functions. So when I'm saying view all, it should be able to do all, view all. So these functions, you know that no, we have to tie with the command, right? So we are saying command, view command. So view command is a function. When I click on this button, this function will be invoked. So let's look at the view command. So what view command is doing, it's simply calling this backend dot view, and then it's calling this update list box. Okay, so this my list box is going to update it. So I'm going to explain you the code, but you should write this code yourself. Okay, if something is not clear, you ask me. Yeah, sounds good.
Yeah.
Okay, so see, so I have to organize my code, even though I could have written backend code or database access code here itself, but to keep it clean. And so this code is just doing the job of dealing with UI. We have this backend. Okay, so we are separating the concerns. We're separating the concerns. So now this is my backend file. This is actually doing, it is doing the connection. It has created a table, and then we have this create. These things we have already seen, right? Connect, cursor, insert, execute, commit, all these things we are doing. Connection close, we should have done cursor close also. Then this is the search. Okay, this is the search, and this is the view, which will get everything. Select star from book. So what is this star? What will this star do? When I say select star from book, what will this star do? So students, what will the star do? What does the star mean? We have just discussed about it, right? Do you remember, guys? What does a star will do? Okay. So see, star, as I told you that no, it will actually get you all the columns. Star will get you all the columns. Okay. And this select star from book will get me all the rows. Okay. Why it will get me all the rows? Because we don't have any where clause, which is filtering the record. So I know that no, this will give me all the rows. Okay. And since there's a star, okay. Okay, where is Parth? Okay, where is Prabhu? You're not there, right? I'm just okay. Let me look at this. Okay, so yeah, so this select star from book will get me. Star is it will get me all the columns, and because I don't have any where clause, it will get me all the rows. This is what we are calling from front end. When we calling from this, we are saying backend.view. So backend, you know that no any other file, Python file, I can include as a module. So I'm including as a module import backend. Okay, import backend, and on this backend I'm calling this view. So this gets me all the records, and then I call this function called update listbox. Now let's look at what update listbox does. Book list is actually this name of this list box. So if you look at this, book list is the name of this list box. So book list is the handle to this list box. I can get to this list box using this book list. So now this this list box may have records which are being displayed earlier, right? So I will have to first clear it off. Because if I don't clear it off, and if I click on view all multiple times, the records will keep on adding. The same records will keep on adding, right? So every time I click on view all, I should first delete the earlier record and then insert all the records once again. Okay. For that, I'm saying, okay, from first row, you delete everything till the end. Okay, so till the end. So for end, tk inter provides me this end argument. Okay. And then I'm passing rows to list box, and then I'm running through the loop, and simply I'm saying book list dot insert, and insert where? Insert at the end. Insert at the end of the list box, and with this data, row data. Okay, row data is just I'm getting in form of no record, right? So I'm just getting in form of record. So I'm just inserting these records here. Okay, so you can see I'm inserting Python, Peter, all that. These are just the row object which I'm getting, which I'm able to insert, which looks like tuple. So right, so every time I am calling, I want to show view command, I have to do the update list box. And this update list box I can use many times. Let's say if I'm doing a search also, when I'm doing search, then again I want to call update list box, because then I have to remove everything and then show only those things which are being searched for. So now let's look at the search entry. Okay, so when the search entry is called, you see that when the search button is called, so we are calling the search command. Okay, we are calling the search command, and then the label text of this is search entry, which is this button, which is positioned at row 3 and column 3. So this is my column 1, column 2, and column 3, and this is my row 1, row 2, and row 3. Yes, so it is row 1, row 2. Generally, basically rows start from 0. So yeah, rows and columns start from 0. So this is actually column 0. This is column 1. This is column. Okay, so this is, where is my list box? List box is at row 2 and column 2. Okay, so this is column 2. Okay, this title is coming actually at labels are coming at column 1. So we are leaving. So there is a column 0. Row 0 and column 0, which is the, okay, this title and this thing is coming at the row 0, and we are using this space as thing. So anyway, so this is the grid layout. You understand that very well, so you can lay out the content anywhere. So looking at the search entry, we are calling actually search command, and when we are calling the search command is nothing but a function. So we're reading from these text fields, and you know how to read from text field because we have defined text variables. We define string variables which are tied as text variables to each entry. Like author is tied to this, so author is tied to this. All these values we are able to get through these variables. Okay, book list, all these things we are able to get from there. So in search command, when this is called, we read all the values, and then simply on backend we invoke the search. So if we look at the search, which is this thing, right? So search, we are just passing default value as some default values. If we are passing no some if we are not passing this any data, then it will use this. If you're passing this any data, it will use that particular data. So what search will do is simply make the connection and do the select star where title is equal to this or author is equal to, they are all connected through or. So it's going to match all of them with or clause. Okay, so that's how it gets that. It then it does a fetch all, and then it returns the rows. So rows are returned here, and then we again call update list box using rows. Okay, so like that we can do search command, then add command again. So this will be invoked, and to add we have these entries here and we want to add them. So these entries first we will read, and then we'll go to the backend, and then we are going to insert this. Okay, we are going to do a backend dot create and view command. Okay, so we go to backend dot create. So this is basically we are creating the record. When we have to create a record, we just simply have to do the insert. Okay, and for primary key, we are just passing null, so we will get a auto increment. Okay, and you can also see that now how this table is created in a very similar fashion, the way we created the product one. Create table if not exist, and ID is the primary key, and then you have other things, title, author, year, and ISBN. So we are able to add entry by calling this create. We are able to call this create here, and then we are able to execute this and then commit this. So this is create done. Update update is little bit tricky. Why? Because when you are selecting this update, you see these values are changing. These values are changing, right? And depending on this only, we have to do update. Now, why it is tricky is because update we will be doing on the ID, and ID is not showing up here. ID is not showing up here. So how do we read that data? how do we read the data? So we'll have to read the data from here. Okay, we have to read the data from here. So now how we will do is, so when we update command is called, we read all this data, and then we are getting the selected row. Now, how do we get the selected row? So for that, there is one thing which you have to see is, so as soon as um, so as soon as so we are creating an event. So whenever I'm doing a selection, an event is being fired. An event is being fired, right? So what is that event? So on list box, that event is actually list box select event. Okay, so this is all events. We know that from Pygame that no, there is events which this UI are able to detect. So this event is tied whenever this event is triggered. It is going to invoke get selected row function. Is going to invoke get selected function, and we are saying that on book list dot bind this event with this function. Bind this event list box select with this function. So when we go to this function, so it is like get selected row, and then the event, we are not using this event. It is just pass. So you can actually print this event and see, okay, it is showing you some values for the event. So there, what do? We say, okay, get the list box current selection. So you book list is my list box, and you get the current selection. And then this is a selected item. So from the selected item, we extract the value. So we get the index. So index is this first value is actually the at the 0th position, which is actually our ID, right? Which is our ID. So we are printing this ID, and then from this, sorry, this index is not an ID. It is the index of this particular row. Particular row. So it is, we are getting this selected item, right? So selected item is, we're getting an object from this book list current selection. So we get selected item, and since there can be multiple selections also, list box allows that multiple selection also, but in this case we are just using one. So we are just looking at the first selection because we are just looking at one selection. So we get that index, and using that index on book list, we are able to get the record, and you can print these records and see, okay, you're getting these values. And then, so using this selection, we have to first change these values also, right? Because when we're selecting here, this is getting modified. So this is getting modified because we are doing title text dot set with these values, selected row, selected 1, 2, 3, 4, right? So the selected row is what we have got, and we have got all these values, and that's how we are displaying it here. And the ID we are keeping in selected row, and this is what is global. We made it as a global variable. And then when we come to update, you see that now we are reading this ID from selected row, and that's the ID at the first record. And then that's what we are passing. Update, we are passing record ID, title, author, all that. And if you look at the back end, it's all update in a simple way. We are just doing the update the way we did in the previous example. You're just simply saying update book, and you're doing all that, right? That's how you will do update. Delete is simpler because you just already have the selected row. You just get the ID, and you pass this ID to this, and it's simply going to delete that, right? So it's simply going to uh, on this ID, it will say delete from book, where ID is equal to the ID which we are passing. Okay. Now so this is will do the delete. Close is actually we don't have any function for that. Close we have just tied to window.destroy. Okay, so window is the window which we have created here. tk enter window, and this provides me a function called window.destroy. So I'm able to call this function using this command. So this command is tied to this. When I click on this, it will just simply invoke this, and this window will get destroyed. It will call this function destroy. It will be destroyed. Okay, so that's how we can actually build this complete application. So I'm going to send this code So, but please use this as a reference. Build this app yourself. Build it yourself. Okay. Guys, makes sense. So we have just gone through the code. I hope it made sense to you. We looked at a similar example, but this is like complete integration, front end and back end. So is it all clear? Any question? Any question? Do you have any question? So I've just sent the code for your reference. Okay, so please build this bookstore application. You know the functionality and you can build it. So guys, will you be able to build it now?
Yeah.
Okay, good. So use it as a reference, the code, but please build it yourself. This will give you a lot of practice and a lot of confidence, because this is a full-fledged app which you are building. Actually, it's a very real software which you will be able to build. So that will give you a lot of confidence. Okay. Tricky parts, wherever the list box selection is there, you can refer to the code. Basically, we are just binding a function with the event. Okay, that's it. When the event gets triggered, we are binding with a function. Okay, so function will be invoked. Right? Any question? Any question? Was it all clear today, or was it kind of bouncer to all of you? Was it bouncer or it made sense?
I mean, it was kind of like it kind of like there's a lot of code, so it's kind of hard to understand. But then, yeah, the way you explained it made it kind of easier to understand.
Okay. Okay, good. Yeah, I understand. Coding is for computers. No, we human beings are good at reading stories. Okay, coding is for computers. So it will take a little bit more practice. You guys just started, right? So just practice. It will become much more clearer to you. Okay. And one more thing, note down your questions whenever you're practicing. If you come across some question, please note it down and ask me in the class or in the lab that, okay, what is this? Why is this? And think through why we are using this, right? It's a very powerful tool. Software coding is a very powerful tool, but you'll have to master it. You'll have to put effort. Once you put effort, you can actually really do amazing things. Okay, you can create wonderful softwares which can do amazing, which can solve big problems. Okay, so do practice, students. Do build this application yourself. Okay. Okay, then if there's no other question, we will kind of stop here.
Okay.
Okay, yeah, so all the best for this building this bookstore. I'll see you next week. Okay, take care. Bye-bye.
You too. Bye.